Hello everyone and welcome to another Fusion 360 live stream. My name is Brad Tallis from Autodesk, and on the keyboards today I have my friend Angelo. What we're going to be doing today is something a little bit different, a little bit more fun. My wife had this glass vase, and I thought, how could I make it look more interesting? And so I actually did this vase, and I'm going to show how you can go about creating some interesting, what I would call organic shapes using some tips and tricks with Fusion 360. Now, this is based off of a video I actually saw from this K Ateen, I hope I'm pronouncing that correctly, where he just did it with a sphere. So I'm going to take it to the next level. So I'm going to show how I went about, for example, creating this vase and then creating some more of the organic looking shapes. So let's dive in. So I'm going to start with a new session. Now, in this example, I started with the glass vase, and I actually modeled this up. I'll walk through here. It's kind of an interesting shape. So you can kind of see the solid glass, and there's like this little air bubble down here. So I actually physically modeled all that. Here is the sketch that I used. Okay, and just kind of created that weird shape. And then of course I just did a revolve, swept that around, revolved it around, added in a fillet on the bottom and a fillet on the top, or a chamfer on the top, and then finally a fillet on the inside. And that's how I created this vase. So if you wanted to do something similar to this, you can. Now it looks kind of wireframe, and the only reason for that is because I added a glass appearance to it. So I'm going to start with this particular shape and then create that organic shape around it. So the simplest shape is a cylinder. So I'm going to come in here and say create cylinder. Now these are primitives. And actually, you know what? I'm going to back up. I just thought of something. I'm going to show you what the end result we're kind of aiming toward and kind of the technology behind it. And then I'll start in. So let me just start with something simple like this. Now we're going to end up using a really cool command called the pipe command. And I'm just going to create a couple weird little lines here. Something kind of like this, and I wanted to show you the power of the pipe command. So here's my my sketch. I could even, if I wanted to, move that point up so it's on a different plane, like so. And then I'm going to go into the form workspace, and in here. I lied. Let me do it this way. I'm going to stop capturing my design history. Let me do form. Oops. Create pipe. Okay. So in fact, you'll notice the preview or the image kind of shows what it's going to do. It's going to connect some curves into like a pipe. So I'm going to go ahead and say pipe. It's asking for my path, so I'm going to go ahead and select all three of these. And you'll notice I get this weird kind of blocky looking shape here. Okay, let's go ahead and make this a little bit larger. I'll say 1 in this case. And again, you can kind of see what this looks like. Now, I'm actually in my form menu. This is kind of the T-splines. This is where you kind of tug and pull and make organic looking shapes. And this is where we're going to end up. You'll notice I can display either box display or smooth display. When I click on smooth display, I get this really cool intersection right here. Okay. I'm going to go ahead and jump over to my segments, and you'll notice I can do more segments like so, and it kind of adds more detail in there. But you kind of notice it starts to tuck in a little bit. Well, if I drag to fewer, notice what happens. It creates these really nice, smooth transitions. Let me crank that up a little bit more so you can kind of see it's adding more density to it. If I drag this down, I get this really nice looking transition between all three of those. So you can almost think of this maybe like a bike frame or a race car frame, a roll bar, or whatever it might be. You can quickly and easily do it with just a couple lines and let the pipe command do the rest. So this is where we're headed. So let me back up here. Let's go back to the vase. So instead of me drawing just a couple lines, we're actually going to use geometry to create those lines. So I'm going to start with a cylinder, primitive. I'll put it on the bottom plane here. And you can see I'm going to start to draw a cylinder here. Now, I want to give it enough clearance that when I add some thickness to it, the vase would still fit down inside the 3D print. So you can kind of see it. That's actually it barely fits in there. So that works pretty good. So you can kind of see this is the end product. And then here's that weird air bubble I was telling you about, and the fillet and all that kind of stuff with this vase. Okay, let me jump back. So I'm going to make this, let's just do maybe like 2.7 in this case. Looks pretty good. And then I'm going to drag this up. So I'm going to start to drag up. Now, why is it red? Well, because it's intersecting an existing model, Fusion assumes that you want to use this profile to cut away the vase. But obviously we don't want to do that. We want to create a new body. Okay. And then for the height, let's just do maybe like 7.5 in this case. I'll say OK. And I'm going to expand open my bodies folder. Now I'm going to rename this guy. We'll call it glass vase. Okay. You're going to see a bunch of bodies appear in here as we go through all these different processes. But basically one builds on top of the other, which builds on top of the other, etc. So this will get fairly lengthy, but you'll see it's going to give us a final result at the end. So I don't need the glass vase anymore. And to add some character, I don't know if you saw this, I angled the top of it. Instead of just having it straight across, I thought, oh, I'll give it a little bit of character. So I put an angle on there. So let's do the same thing with this guy. So I'm just going to click the top face and say move. Now I'll just look at it kind of from the front. And you'll see I can rotate. I can move this face up and down, but I can also rotate this face. You can kind of see how it's just rotating. Now, the pivot's slightly off center in this case. It doesn't really matter in this example, but I could move that pivot if I wanted to. So you can kind of see how I could snap it to the center, say done, and then rotate it so it's rotating right around the center if I wanted to. So let's just do maybe 35 degrees in this case. So I'll say OK, and I've just moved that face. Now, many different ways to create this. I could have drawn another sketch, drawn a line, extruded, subtracted that away, but I think the move command is way faster, and I can come back into my timeline and make changes to that if I needed to change the angle if I wanted to. Okay. So we have our basic shape. In fact, if I turn the glass vase on, you can kind of see how tall that's going to be comparative to the vase. Okay. So now what I need to do, a lot of the stuff we're going to be doing next, I don't want to be capturing design history. So I'm going to do a quick fillet on the bottom. Let's just do 0.1 just to give it a little bit of a shadowed edge on the bottom. But then I'm going to right-click on the glass vase up here and say, do not capture design history. Now, why am I doing this? Well, notice across the top are different tabs. We've got solid, surface, sheet metal, and tools, but we don't see one that says like mesh. I want to be able to edit a mesh. And to do that, that's only available in the direct modeling side of things. So you'll notice when I turn off my timeline, I'm going to lose my design history. I'll say continue. But now we see surfacing, form, mesh, etc. So these didn't show up until I turned off my timeline or turned off capturing design history. So that's the one thing you have to remember with this methodology. Okay, so now what we're going to do is I want to change this into a mesh. Because with the mesh, we can, remesh, reduce. We can do a lot of different things with it. So I'm going to right-click on Body 2, and you'll see there's a command called brep to mesh. So whenever you're modeling something in Fusion, it's called a brep. So when you do like a sphere, when you do an extrude or whatever, it's a watertight model. That's called a boundary representation. So brep is the shortcut. So what we're going to be doing here is we're going to be converting that watertight model into like a mesh, which you can almost think of as like paper thin. And you'll see this as we go through. So I'm going to right mouse click on this guy and say brep to mesh. And watch what happens to my bodies over here. Okay, well, as soon as I say okay, you'll see it. But you'll notice it's breaking down that cylinder into a whole bunch of triangular or tessellated faces. Okay, so that's the easiest way to do a curved surface. And so that's why you see all these little triangles. Now, we don't want it to be this complicated. So over here, by default, it might not be, preview mesh might not be checked. So you would want to go ahead and say preview mesh, and it kind of shows you what it's going to do. And then it tells me how many triangles. So in this case, about 3,000 triangles. What I'm going to do here is I'm going to change this surface deviation. So watch what happens as I start to drag this to the right. You can see it's still trying to keep making triangles to do the cylindrical surface, but it's using less of them. So the farther I go, the less triangles we have. Okay. So in this example, I don't want it to be overly complicated because then everything would kind of overlap each other. So I'm going to drag this all the way to the right as far as I can. And then I also have this maximum edge length. So you can actually change this guy. So notice as I drag it down, it's saying the maximum edge length can only be about 0.6 inches in length. Well, I could crank that up and it's going to basically remove even more and more detail. So you can kind of see as I keep going, I'm saying 7, right? For example. And so we've lost quite a bit of the vertical detail. I've found around 2 is pretty good, especially if you're going to like 3D print this or something like that. But again, go ahead and play around with the surface deviation and your maximum edge length. So this looks pretty good. I'll go ahead and say okay. And you'll notice my object looks a little bit different now. We kind of see these weird shadow things, and that's because it's actually broken down into triangles are kind of defining the surface of this model. So instead of a perfect curve, these are actually straight line segments. So there's a straight line segment there, a straight line segment there, etc. But there's enough of them to make it still look like a cylinder. In fact, this is actually a pretty good view. You kind of from the top, you can kind of see those line segments. Okay, so that was converting it to a brep to mesh. Okay. Then I'm going to, if I were in the solid tab, I would make sure I'm in my mesh tab. Okay. And this gives us even more options. So for example, I can remesh and I can reduce. So I'm going to come in here and say remesh. And this is what's going to give us kind of this organic looking style. So I'm going to come in here and say remesh. And now notice we actually have 3 bodies in here. And one of them looks like, instead of a solid cylinder, it kind of looks like, a bunch of little faces. So this is the icon for a mesh. So what is the mesh faces or body? So you'll notice if I hover over it, it allows me to pick individual faces, which obviously would take forever. So I'm going to come over here and just click on the mesh body. It selects the whole thing. Okay. Then I'm going to click on preview and notice what happens. Okay, I get this weird looking blob, but notice the triangles look different. So instead of being all even and perfect, they're kind of, a little bit more organic. But obviously it's kind of destroying my model more than I wanted it to. Okay, so let me just kind of go through this remesh menu. You'll notice it says meshing type is adaptive. And so what adaptive is doing is on curved surfaces, it's basically trying to keep enough triangles to define the shape. But where there was, more like flat areas like this top and the bottom, it's going to use less triangles. So you can kind of see, it's a little bit harder to see, there's quite a few triangles here, but they're a little bit farther spaced up here. So that's what adaptive does. If I say uniform, you'll notice that all of the triangles are the exact same size, or pretty close to the very exact same size. I've had better luck with the organic doing the adaptive because the 3D model kind of defines the shape of it. So I like adaptive. Okay. Then you have this density, which I could crank down, and you're going to see it's going to really sort of destroy the shape of that. Let me crank that up a little bit. And there you can see by adding more triangles, it's defining a little bit better that edge, right? So obviously the more triangles you have, the more your shape is going to look like the original. I'm going to set that back to 1, which is what the default was. Okay. Then we have shape preservation. So, it's going to basically, this is almost like a random number generator or whatever. It's basically trying to keep as much of the shape as it can as I drag that up. So it's still using the adaptive. But you can kind of see I'm starting to get a little bit better shape up there, but I'm still getting some weird stuff on the back. I'm going to leave that at 0.5. So pretty much I'm going to leave everything default, but I'm going to turn on this preserve sharp edges, and notice what that does. It recognized that angled face had a sharp edge, so instead of trying to round these off, it's going to preserve those sharp edges. Okay, so that's a really powerful option. If you turn it off, you can kind of see it just trying to make the shape look as close as it can, but by preserving those sharp edges, I get a much better result. Okay, so let me do that one more time. I'm going to come in here and say remesh. What is the mesh? I'm going to select that guy. I'm going to leave it adaptive. I'm going to leave it 1. I'm going to leave it 0.5. And I'm going to turn on preview. And I'm going to turn on preserve sharp edges. I'll say okay. And I now have a mesh body still made out of a whole bunch of triangles that kind of look like this. So the next step is the reduce, because there's way too many triangles and they're all like straight lines and stuff. This would look kind of boring, honestly, to 3D print. So I'm going to come in here and say reduce. And it looks pretty similar. So the first thing I'm going to do is I'm going to turn on the preview so we can kind of visually see what's going to happen here. I'll go ahead and select my mesh body again. Hopefully. Let me do, there we go. I'll click on that guy. I'll click on preview and notice what I get. And it's kind of hard to see with the blue, but what we're doing is we're changing the density. So it's taking all of those triangles and now we're reducing the density or the face count or the tolerance. So right now it's density. If I went to face count, you could see we can say, I want it to be 400 faces, and you can see how it added these extra lines in here. But if I were to drag this from 400 down to about 200, you're going to see it removes a lot of that. And now we're down to about 200 faces all the way around. I can also say density, and it's pretty much the same thing. So if I drag this higher, we're going to have a lot more lines. Okay, but again, a lot closer together. You might run into issues of it overlapping and stuff like that. So in my playing around, I found about 0.15 is pretty good for stuff like vases, etc. So I'm going to type in 0.15, and you see we get some cool looking lines here. This will look actually pretty neat, I'm thinking. It's these big triangles. You can kind of see these big triangles, etc. Okay. I'll go ahead and, again, I'll leave it adaptive. I could say uniform, but then you're going to get a weird result, right? Where it's trying to keep all the faces and edges uniform, but in this case, we want it to be adaptive. And you can already see the kind of the organic stuff going on here. Okay, so there is our reduced and our remeshed cylinder. And even the fillet at the bottom, you can kind of see how it's, you know, created these little triangles to try and create that little blend on the bottom, that little fillet on the bottom. Okay, so the next thing I want to do is I want to convert this back to a B-rep. So I'm going to right-click on Mesh Body, and there's an option in here called Mesh to B-rep. And the reason for that is when we go to use that pipe command in the form, it needs like B-rep edges, kind of like what I drew with my sketch. Those were, you know, basically B-rep edges or lines. So that's what we need to do with this guy. So I'm going to right click and say Mesh to B-rep. Pretty simple. What's the mesh body? I already had it selected. Operation, it's going to say new body. Watch what happens. It turns my mesh off and it created a new body, and now you can see those lines are very defined and black and stuff like that. So you can really kind of see that this is a solid body, where this is a paper thin body. This is an actual solid. In fact, if I were to section analysis, I'll just click on a face and slice through, we can see that that's an actual solid watertight body. Okay, so that was mesh to B-rep. So now I can start coming in and using this model, we're going to use the pipe command. Now I started really simple with just 3 lines. Now we have a bunch of lines. And if I draw a selection box around this, you'll notice it selects not only edges, it selects all the faces, it selected the whole body. Well, the pipe command requires edges only, okay? Basically a path is what it's looking for. So I only want to select these edges, and that would take quite some time for me to select all of those. So here's a neat tip. I'm going to go to the select menu, and I'm going to go to selection priority, and you can kind of see the priority. So it's going to, if I drew a selection box around the whole thing, it's going to select it as a body first, and then it would select all the faces, and then it would select all the edges, etc. Okay? So I'm going to instead force it to only select edges. I'm going to say this is the priority. So I'm going to click on that guy, and watch what happens now when I draw a box around. You'll notice it only selected the edges. So that's a cool little tip. Now, with that said, be careful, because if I go to my selection filters, you'll notice what it basically did is it turned everything off, and the only thing it's letting me select are body edges. So you might go to do something, 3 or 4 steps from now, you go to select a face and it won't let you. And that's because it is only letting you select body edges. So just be aware of that. Now, and you'll see that here in just a moment. Okay, so I drew a box around the whole thing. It selected all of the edges, but you'll notice it also selected the edges on the top. And so it would actually create, geometry that would block the top and not allow the vase to enter. So I'm going to control click these lines here, Let me kind of rotate around so I can kind of see everything, maybe zoom up a little bit. So I'm going to unselect these lines from my selection. And so now I can kind of see I don't have any of the edges along the top face selected. I could also analyze, and it's a little hard to do, I could analyze my model and unselect any edges that I think might be too close together or something like that. So for example, I might come in and unselect that edge. So I do have a little bit of control over which edges are actually going to be generated using that pipe command. So I'll just unselect those guys. Then I'll come in here and say create pipe. Okay, now we get this weird looking shape. So what's happening here? Well, it's basically creating a pipe using all of these paths, but it looks like a big blob. Well, the reason for that is the diameter of the pipe is huge. Right now it's 1 inch in diameter. So let's go ahead and change that to maybe like 0.1, and be patient because it's having to think on all of these paths and stuff like that. So it might take a few seconds for it to update, but now you can see, let me zoom up here, you can kind of see what's going on. Okay, smaller diameter, but it's following all of those lines. It's kind of hard to see, but you can kind of see this pipe right here is following this path right there, and this pipe right here is following this path right here. Okay, so I made the diameter smaller, 0.1 in this case. The next thing I'm going to do is you'll notice they kind of come to a point right here. Looks like they're kind of tapering down with like arrowhead type things. I'm going to switch to smooth display. And again, this might take a few seconds for the display to update, but watch what happens to these intersections when I switch to smooth display. And there you go. You can kind of see that bicycle frame pipe example I was giving you earlier. So it's connecting all of these together. In fact, if we look at let's kind of look at something like this guy here. So you can see it's a little hard to see with all the blue lines, but it's bringing in multiple paths all to one point right here, and it makes a nice looking patch basically. Okay, so that's the smooth display. The next thing I like to do is I like to go to segments, and you'll notice all of these horizontal lines. It's defining quite a few segments. Let's zoom back up here. And the more segments you have, the tighter the curve and all that kind of stuff. So if I were to bring this down to fewer, and it was already down there, so I usually click up to kind of reset it so you can see. Let me click up here. Yeah. Again, you have to be a little bit patient as it's thinking, and that's great. Wait for the program. Let's see. I was clicking too fast. There we go. Okay, so here is where it is kind of between fewer and more. So you're going to see it's going to generate a lot of lines. Then I'm going to bring this pretty far down. So I'm going to click there. And again, I'm going to wait for a second, and it should update. And watch what happens, especially in this area right here. You're going to see a lot less divisions. And again, it's thinking. I might have gone too far. And it's going to create a smoother transition. So you can kind of see a lot fewer transitions, and we get these kind of nice curved sections, and it's going to create that more organic looking shape. Okay. So I usually crank the segments down into the fewer, and I'll go ahead and say okay. Now you'll notice we have a couple more bodies in here. We started with body 2, and now we've got 3 more after that. So what we've done is we're working on this body 4. It's a mesh, and now it's thinking. It's trying to complete, saying, is this a valid mesh? It's doing all the calculations, and now we have this image like you see right here. Well, let's turn off body 3 and we can now see through the part because we used body 3 to give us all these edges, right? Well, by using those edges, we were then able to create, with the pipe command, this organic looking vase. And again, notice at the top, we don't have any lines going across, so the vase would be able to slip down inside of there. Okay, I know this is kind of confusing, lots of steps to get to the final thing. So the next thing I'm going to show here is this is a Tspline body. Okay, I can't 3D print this right now. It's not a valid body. I want it to look like this body 3, like that little icon there. So I'm going to right mouse click and say convert. And notice the option T-splines, which is what this little icon is, to B-rep. This is exactly what I want. Okay, so I'm just going to go ahead and say okay. Now what it's going to do is it's going to analyze this and see if it's a valid T-spline, and if it is, it's going to convert it to a B-rep. Now you'll notice I got an error message. Edges or faces may be crossing. Review in box mode. Well, instead of box mode, I'm just going to zoom up, and you're going to see a bunch of these red areas that it's complaining about. And this actually makes sense. Where all of these arms are coming together, they're kind of overlapping, they're kind of folding in on each other and stuff like that. So Fusion is unhappy, unfortunately, and it won't let me complete this. It won't let me convert it from a T-spline to a solid body. And to do that, I would have to fix all of these areas, and that would take forever, and I would probably still not accomplish that just because of how organic this is. And you can kind of see as I zoom up here, you can almost see how like these are intersecting each other, and that's what I want, but mathematically Fusion is not happy. Okay, so this is where I spent a little bit of time figuring out how can we get this so I could actually physically 3D print this or resin print it or whatever. And there's a really cool command called boundary fill. It's underutilized. I'm going to show you how this thing works. So under the, let me go back to my solid menu here. Under the create menu, you'll see a command called boundary fill. And what this allows you to do is to basically use volumes to create a new volume. And you can kind of see the example here. They've got kind of like this wine glass thing stuck inside a block. And you might say, hey, I want to fill that wine glass with the material from that block, almost like you're pouring water into that wine glass. So instead of doing a revolve, you're just using a big block and saying, keep what's inside the wine glass from that block. And that's kind of what the image is showing there. I know it's a little bit confusing, but it's basically replacing that cube. It's using that information from that cube to fill in the wine glass. And so we're going to do the exact same thing. I want to use the information from this form, this T-spline form, and I want it to be a solid model. So I'm going to start with a solid model. So I'm going to come in here and say create a cylinder. I'll put it on that bottom plane, and I'm just going to draw it larger and taller than it needs to be. Okay, so it's encompassing the whole organic looking vase. I don't care about the diameter or the size or anything like that. And you'll see I now have another body. Now I do want to make sure it encompasses the whole thing, so I'm going to move this guy down just a little bit. Okay, so now this body is fully inside the cylinder. Okay, then I'll go to boundary fill and watch what happens. So I'm going to start by clicking on body 4, and when I click on that, you're going to see a little box appear on the screen right here. And this is what we call a cell. Okay? And this is basically what allows you to select what do you want to keep and what do you want to get rid of, or what do you want to use instead. So I've selected the tool. I'm also going to select the big cylinder, and watch where the box appears for the big cylinder. It appeared up here, and you can kind of see it's pretty much in the center of that cylinder. Okay, so I've selected both my tools. I've selected the organic vase, and I've selected my cylinder. Then I'm going to come in here and say select cells, and I want to keep the solid body, which happens to be the cylinder. So I'm going to click on that box right there. Then the operation, I'm going to basically cut. So we're going to cut the organic shape out of this cylinder. And again, this will make more sense as soon as I say okay. So watch what happens over here. I'm going to go ahead and say okay. And I now have two bodies displayed. Let's turn off the mesh and notice this guy. We don't see all of the variations. We don't see all those lines or whatever. This is a solid body. By using that boundary fill, we were able to convert basically something that didn't work into something that does. In fact, if I were to section analysis this guy really quick, let me click maybe this top face here, and let's just slice down a little bit. I'll zoom up so you can kind of see what's going on. We can see that, oops, too far, that is a solid body. It's not hollow, it's not paper thin or anything like that. And as I drag this up, we can kind of see how this, almost like it's 3D printing, you can kind of see how, sure enough, those are solid bodies. Okay. Let's go ahead and add an appearance to this guy. I'm going to hit A for appearance. So you can kind of see all my different appearances here. Let's just make it out of maybe metal in this case. Let's do gold. I'm just going to drag gold onto there. Let's turn the glass vase back on. We can see, sure enough, that fits inside of there. Maybe I want to see what this would look like in a render, so I'm going to switch over to the rendering workspace. And let me zoom out a little bit. I've got a HDRI image of like a bathroom or something, so I could position this vase in the bathroom. Go ahead and hit render, and we can kind of see what this thing would look like in reality even before we manufactured it, for example. So, and this HDRI image is reflecting in that material, and you can kind of see how the glass looks pretty realistic, etc. So you can simulate what this is going to look like even before you manufacture it. Okay. So that's the basic idea. Like I said, it's multiple steps to get to where we wanted to get to, but it allows us to create some cool shapes that would take forever, I would think, to model. Hopefully, I'm rendering now, so let me turn that off because it looked like it was making the video jumpy. Okay, so let's take this one more level deep. I'm going to do the exact same thing, and instead of a simple shape like a cylinder, let's do more like a vase, okay? So yeah, I just looked over the chat. Empery Consulting said, boundary fill is a difficult tool to get your head around. I agree. I would practice with cubes and spheres and wine glasses and stuff like that before you're doing organic, weird-looking things, just to see what boundary fill does. There's a lot of YouTube videos out there that kind of show the power behind it, but it is a very powerful tool, and it can get you out of problematic areas. For example, maybe you get a model that you've imported in and it's so corrupt that you can't do anything with it. You could potentially draw a big box around it, do the boundary fill just like I showed, and it might heal that geometry to where you could finally edit it or make changes to it. So keep that in mind. Okay, so I'm going to go a little bit faster this time. We're going to do the exact same methodology, but this time I'm going to create a more organic looking shape. So I'm going to just do a spline of like a vase or something like that. So let's just do something like this. Okay, I want the bottom to be flat. So I'm going to select this line right here on my spline and say make that horizontal. And this is the tangency direction and weight. So if I were to drag, oh, and there it is. I just got burned by what I was going to tell you earlier. I'm trying to drag this handle and it's not letting me. Why is that? Well, it's because we changed our selection priority and it's only allowing me to select body edges. So I need to come back here, say select all, and now I can grab that and change the weight of it. So you'll notice on any of these, I can change the weight of this spline. Okay, so we're gonna make that one be horizontal. I might bring this guy up a little bit like so. Okay, I do need this to be closed. So I'll just draw a line straight up and straight across, like so. Okay. Then I will use the revolve command. Create revolve. What's the axis? This is the axis. I'll say okay. Now, here's another tip. I hope you guys know about this. Here's my vase. I'm not overly happy with it. So I'm going to turn on my sketches or my sketch. I can actually physically change by dragging my spline around like so, and I get the instant preview of what this is going to look like. So instead of having to go back to my sketch and make changes, I'm able to just basically drag my spline around and get the shape that I want. So that looks better. I'm happier with that. So cool little trick just by turning your sketch on. Okay. I'm going to switch to do not capture design history. That way it'll give me my mesh tools and all that kind of stuff. So we'll expand open bodies, B-rep to mesh, and notice all of the triangles, ton of them, right? So I'm going to crank this surface deviation all the way up. Still looks like a vase, but much fewer triangles. My preview is on, so I can kind of see what that looks like. Same thing with my maximum edge length. I mean, obviously these are much shorter than 2 inches, so I'll just leave that alone. I'll say okay. Then I'll go into my mesh, and we're going to do that remesh and reduce. So I'm going to say remesh. That's my mesh body. We're going to do adaptive. Let's turn the, I'll turn this off so you can see what's going to happen here. When I turn on preview, you can kind of see how that destroyed the top. But if I turn on preserve sharp edges, it kind of keeps that looking nice. I'll go ahead and say okay. So we'll just leave that the same, the way it is. Okay. Then I will do the reduce, and this is kind of where the magic happens, right? So I'm going to turn on preview, and we can see, oops, sorry about that. We can see how it broke it down into a smaller density. It has a lot less triangles. I have my preview on, so if I were to drag this up, I could kind of see what this is going to look like. And this is how you go about making, much finer shapes. And this is actually kind of confusing because it's actually hollow. There's an inside wall and an outside wall, and the inside wall has stuff on it and the outside wall has stuff on it. So I could show how to do that also. But again, I found like around 0.15 is pretty good. If you go too small, 0.05, you're gonna get, it just basically destroys itself. So just kind of mess with the numbers until you get something that looks pretty good. So I'm gonna say 0.15. I'll say okay. We get that guy. We convert that to a B-rep. So now we have the body that has the darker lines on it and all that kind of stuff. So there's that body. Well, let's jump to the form. This is now where we're going to do the pipe, but we need to select all the edges. So once again, I'm going to come in here and say edge priority. I'll draw a box around the whole thing. I'll unselect the edges that I don't want to have the pipe follow. So I'll do something like that. And again, if I wanted to, I could select any of these. You know, like for example, let's make this so it's fairly open right there. So I unselected those guys. I'll say pipe. And again, depending on the complexity, depends on how much time it takes for it to do a preview and all that kind of stuff. So you can kind of see it's thinking for a minute. It remembered my last diameter, which was 0.1. And now you can see, for example, it didn't create these segments on those lines that I unselected. So I'm going to leave it 0.1. I'll go ahead and go to smooth display. It takes a minute for that to appear, but you'll look at these intersections here and watch what that looks like. In fact, I'm going to zoom up on it once it's finished generating. So there we go. Okay, then I'm going to go to my segments, and this is that thing I was telling you about. It kind of remembers fewer, but you'll notice there's quite a few. So I basically click up here. I wait until it kind of generates using this particular number, whatever that is on the slider. So you'll see, and it might even be pretty similar to this. It'll probably have about the same number. Yep, it didn't even really change. Now I'm going to come down here and click on the fewer, and it'll take 10 seconds or so, but watch these intersections. So instead of being kind of sharp, you're going to see them be a lot more organic and kind of almost like they're pulled apart and stretched a little bit. So it'll take a second here, but it's going to use fewer segments to define the curvatures. And again, this is a fairly complex model, so that's why it's taking longer. Hopefully not too long. Okay, while it's thinking, I'm going to switch over. Let's, whoops. Let me take a look at, hopefully all the questions are going good. Okay, so Dan asked, what's the deal with the black hole in the front of the vase or whatever? That was just the reflection. So right here is what he's asking about. Watch what happens when I rotate. Okay, it kind of goes away. So this is actually the light reflecting off of these surfaces. So yeah, great question. And it depends, again, like even like how close up you are. So you can see like there's black spot right there. That's just the reflection of the environment on the model. So yeah, great question there. Okay, so it updated. It took a while, but you can kind of see how it updated. And a lot less segments. In fact, there's basically 2 segments for each of these arms. Sometimes 3, depending on the length of the arm. So I'm gonna say that's good. I like this organic looking shape. I'll say okay. And it's going to take a second to finalize, and I'll save you guys some time. I'm not gonna try and finish the form. It'll fail, right? It'll give me those red intersections and say, this is not a valid form. So we're gonna do the boundary fill one more time as it's thinking. So be careful. Don't do something like super crazy with 10,000 faces or whatever. But now you get that particular shape. I'll turn off body 2, and there's that vase, and it's hard to see, but there's the opening that we made. Yeah, there's so much geometry in the background, it's kind of hard to see, but there you go. Okay, so you do have control over what this is going to look like. Okay, so let's do the boundary fill really quick. So I'm going to do the exact same thing. I could use a sphere, honestly, but since the vases are kind of cylindrical, I just chose the cylinder, so bigger than it needs to be, taller than it needs to be. And then I need to move that guy down. Like so. I'll say okay. Want to make sure it's fully enclosed, which it is. Boundary fill. I'll start by selecting the body, and I do it one at a time. I could do both at the same time, but I like to see where the cell icon shows up, because that allows me to figure out which one do I need to click on, which is right there. I'll go ahead and add in the cylinder, and I'm assuming its cell will show up a little bit higher up once we add that in there, and sure enough, there it is. So then I have to click on select cells. I'll say cut, and you can see there's lots of options in here. Intersect, we could join. Each of these would give you different results, and this is what M4 was talking about. You kind of need to figure out what's the end result that you want. Do you want the liquid from the cylinder to end up inside your wine glass? Do you want the wine glass to be cut out of the cylinder? I mean, you have a lot of options in here. So we're going to say cut. I'll say okay. And we now have a solid body. And there you go. You don't see any of the transition lines or anything like that anymore. We could add a material to this. So maybe instead of metal, let's do like a metal flake paint. Let's just drag that on there. See what that looks like. And you can kind of see the metal flake paint and its reflections and all that kind of stuff. So, okay. So with that, this was a little bit more kind of a fun one, you know, how you could take something as simple as a vase and really kind of make, you know, change it up, make it look a little bit different. I just did this on my 3D printer really quick. It printed last night. So I'd probably make it a little bit thicker. Some of the posts were pretty thin. But my wife actually saw it. She's like, hey, that's pretty cool. So I did something right. So with that, I want to thank everybody for attending. Angelo, thanks for helping answer the questions. And hope to see you on a future live stream. Have a good day.